Welcome to the Explainer! Today we're going to dig into a question that's, well, literally foundational for our planet. How in the world did Earth get its continents?
So you look out across the solar system, right? You've got rocky planets, you've got gas giants, but only one has this: continents. These huge land masses floating on the mantle that are the reason we're all here. And you know what? How they actually formed is one of the biggest mysteries in geology. Seriously, scientists have been arguing about this for ages.
Right. So the mystery isn't just about how they formed, it's about when. Did they build up slowly and steadily over billions of years, or was it something a lot more explosive?
Okay, so this whole debate basically splits into two camps. Think of it like this. Was Earth a patient builder, adding a little bit of continent every year for billions of years? Or was it more of a binge builder, creating huge chunks of land in these massive, dramatic bursts, and then doing nothing for long stretches? The crazy part is, for the longest time, the evidence pointed to both.
So let's play detective. We've got two conflicting stories. Let's look at the evidence, starting with clue number 1, the story that's written in ancient mud.
Okay, so you've got these ancient rocks, shales, which are basically just old compressed mud from eroded continents. When scientists look at their chemistry from samples all over the planet, they all tell the same smooth story. It looks like a steady, continuous growth over time. Super neat, super clean. Case closed, right?
Well, not so fast, because then we have clue number 2, the igneous rocks. Now, these are the rocks that are born directly from magma bubbling up from the mantle. They represent brand new crust being made. And their story? It's completely different. This is where things get really complicated.
Yeah, instead of a smooth line, the data from these rocks looks like a heartbeat monitor during a panic attack. You see these massive spikes of activity, huge global pulses where tons of crust was made all at once, and then quiet. So what gives? Which story do we believe? The steady trickle from the sediments, or these huge dramatic bursts from the magma?
To figure this out, scientists realized they had to go back to basics. They had to look at the actual recipe for making a continent. And you guessed it, that just led them to another, even weirder mystery.
So making a continent is kind of like a two-step cooking process. Step 1, you take basaltic magma from the mantle. Step 2, you sort of recook it. And when you do, it separates into two things: the light, fluffy stuff that becomes the continents we live on, and this really dense, heavy gunk that gets left behind.
And here's where it gets wild. That light, fluffy upper crust, it's only about 14% of the original mix. It's just a tiny fraction of the total stuff that gets cooked up. So if you run the numbers on that 14% means that for all the continents we have, there should be this enormous 77-kilometer thick layer of that heavy, dense residue sitting right underneath them. 77 kilometers. That's massive. But there's a big, big problem.
Where did it all go? I mean, we've used every tool in the geological playbook to look for it, and it's just not there. It's gone. The only way that makes sense is if this super heavy layer was so unstable that it just peeled off and sank back down into the mantle. So it was made, and then almost immediately it was lost.
This is where our detective story gets its hero. To solve this whole mess, the conflicting growth stories, the missing crust, scientists needed a witness, something that could survive the entire violent process: the creation, the cooking, and the destruction. They needed a survivor.
And that survivor is the zircon. These things are incredible. They're tiny, microscopic crystals, but they are nearly indestructible. Think of them as perfect little geological time capsules. They form in cooling magma, lock in all the chemical data from that exact moment, and then they can survive for billions of years through anything: erosion, getting melted down and reformed, you name it.
So here's the superpower of a zircon. In one tiny grain, you get multiple clocks. You can find out exactly when the crystal itself formed. You can also figure out the crust formation age. That's when its parent material first came out of the mantle. And you can tell if that parent material was pure, fresh magma or if it was just old, recycled stuff from the surface. It's like a complete birth certificate for a piece of the Earth's crust.
And this is the key that finally unlocks the whole mystery. All that information, locked away in these little crystals, is how we can finally make sense of those two completely different stories about how the Earth grew.
It really came down to the oxygen isotopes. That was the magic bullet.
Because with that data, scientists could finally sort the zircons into two piles. Pile 1, zircons from brand new magma, straight from the source. These record actual continent-building events. And Pile 2, zircons that came from magma that had melted and mixed with old surface rocks and sediments. They're just recording the recycling of old crust.
And when they did that sorting, boom, the answer was crystal clear. The zircons from the deep, new magma, they showed the exact same pulse pattern, those big bursts of growth we saw in the igneous rocks. So what about the sedimentary story? Well, that was just a blurry, averaged-out picture, because it was mixing zircons from all different ages and sources together. The igneous record, the fast and furious story, was right all along.
So why is that sedimentary record so smeared out? This is maybe the most mind-blowing part of the whole study. It's because there's an unbelievable time lag. New crust can be created and then just sit there for up to 1 billion years before it erodes enough to actually show up in the mud that forms those sedimentary rocks.
So you see, the two clues weren't actually in conflict. Not at all. They were just telling two different chapters of the same epic story. The igneous rocks were the birth announcement, the explosive, dramatic creation of the continents. The sedimentary rocks, they were the census data, recording when that new material finally got worn down and joined the rest of the world, sometimes 1 billion years later.
Okay, so once this was all figured out, it forced a total rewrite of the history books. Scientists had to completely recalculate how fast the continents were actually built. And the new number, based on what the zircons are telling us, is just staggering. On average, 9.3 cubic kilometers of new continental crust was created every single year.
Now, to put that into perspective, that's nearly 3 times higher than what we used to think. The old estimates were way off because they were based on that blurry, time-lagged sedimentary record. This new number means that the early Earth was a far more violent, dynamic, and productive planet than we ever gave it credit for.
So, what does this all mean for the big picture? Well, if you're building continents that fast and in such huge bursts, it suggests the engine driving it all was different back then. It probably wasn't the slow and steady plate tectonics we have today. It points to something much more powerful. Something like massive superplumes of heat rocketing up from the deep mantle and creating continents in these giant, catastrophic events.
This completely changes how we think about our planet's childhood. It wasn't a slow, gentle process. It was hot, violent, and incredibly dynamic. And it leaves us with this huge, lingering question. If the very ground beneath our feet was forming this fast and this furiously, what else about the story of early Earth, and maybe even the dawn of life itself, do we need to completely rewrite? Thanks for joining me on this one.